Ladies and gentlemen, so this is a response to Sleeping Warrior that ever so kindly challenged me to show how sextants work on a globe. And this conversation with Sleeping Warrior actually came on the back of a video by Flatzoid. And what Flatzoid had done is snip out a little section from a video from 2012, so way before Flat Earth became a thing. And in this video, the original creator, who actually claims to be a United States Navy navigator, draws this right-angled triangle with a horizontal line from the observer to the GP of the star. Now obviously this is wrong, so I told Flatzoid that and said I'd go over and let the original creator know. Flatzoid of course doubled down and said, he must be right because he was a captain in the Navy. Now I don't give a shit, so he's still wrong. So I went over to the channel and pointed out the error, but given this video has almost 500,000 views, obviously I'm not the first one to let him know, and at some point he had already updated the description to acknowledge that. However, the actual math needed to perform celestial navigation involves trigonometry on a sphere, which is very advanced math. And as such, you should watch this video knowing that right-angle trigonometry is not actually used in navigation because the Earth is a sphere. So Flatzoid got massively owned by his own source, which I found incredibly hilarious. Anyway, let's have a look at Anthony's video.
Okay, this is a short video dedicated to Ruhif. Ruhif is a smarmy, patronising, condescending prick.
Good morning, Anthony. I love you too, champ. Mwah. Handy tip before we start though, don't let Nathan catch you using Muppet vision, or he might want to stick his nutsack in your mouth and ask you how salty his balls are.
Sextants do not work on a globe, for a variety of reasons, all of which are completely ignored by the anti-Flat Earth cult members.
Or the other possibility is that we've addressed all of them a million times and you've just ignored them. But I get it, Anthony. Nathan's channel's dying, and that means your cut of the super chats is dying as well. So you guys need some content. I get it. Right, so first question is this one.
A legitimate question is, how do you get the GP distance? The distance from the observer on the right. There's Ruhif stood on the ball. Notice I've got the ball underneath him.
Right, so if you had been listening, you'd know that you don't need any triangle to calculate the distance from the observer to the GP of the star. The way the geometry works on a globe is like this. You have me, the observer, somewhere on Earth, measuring an angle to a star relative to horizontal. Now there's been some incredibly silly talk in the last few days from the likes of QE and Mitchell from Australia, who both claim that the simple act of measuring an elevation angle proves that the Earth is flat. Now I already feel a bit dirty addressing this because it's really the lowest of low-hanging fruit. When we say we're measuring an angle relative to a horizontal plane, all we mean is that we are measuring the angle relative to the direction that is perpendicular to down. And that's what autolevels and theodolites do. They have an internal mechanism that's effectively a plumb bob, pointing straight down, and then the device constructs a plane that is perpendicular to it. And as you can see in both cases, that line does not coincide with the surface. On a flat Earth, it will be parallel to the surface, whoop-de-doo, and on a globe, the surface will drop away from that horizontal plane. Now, if you're using a sextant instead of something like a theodolite, then most of the time you'll be measuring the angle between the horizon and the star. And since the horizon is below horizontal, that's why you need to make the horizon dip correction, which is also called the height of eye correction. And that leads me to my first question for Riley, but obviously any of the flirts can chime in. So question is, how do you derive the horizon dip correction on a flat Earth? Now, if you saw my previous video, you'll see that the almanac calculates the correction explicitly from the Earth being a globe, and it incorporates refraction. So what's the explanation, champ? If you want to borrow the calculations from the almanac, then you're gonna need R for that. I also noticed that since this sextant argument started, that people have stopped saying that the horizon rises to eye level. And that makes sense, I guess. If you want to claim the sextant as FE proof, then you have to also accept the horizon dip correction. Anyway, back to working out the distance over the ground to the GP. So we've established a horizontal, either using a theodolite or maybe something like a bubble sextant, and measured the angle to the star. Or we've measured the angle between the horizon and the star and then corrected for the dip. Either way, we have angle alpha. Now the key thing here is that because the stars are so far away relative to the size of the Earth, then these two yellow lines are effectively parallel. So let's assume that the star we're looking at is Polaris. So the GP is the North Pole in this diagram. Now, according to astronomers, the distance to Polaris is 434 light years, which is 4.1 quadrillion kilometers away. Now, that's 4 with 15 zeros after it. So we'll take a guess here and say those yellow lines are about 5,000 kilometers apart. So if you want to actually use a triangle here, then those two lines are way less than a billionth of a degree apart. So yeah, let's just call them parallel. Anyway, if you successfully graduated the 5th grade, you'll see that this angle beta is just the complementary angle to alpha, and it's also the same angle formed by this sector of a circle. So let's say that alpha is measured at 40 degrees, then we know that beta is 90 minus 40, which is 50 degrees. And on a circle with radius 3959 miles, we have a circumference of 24,875 miles. So if we want to know what 1 degree of that circle is, that's where we get 69 miles per degree. And if we measure 50 degrees, then we just multiply by 69.1, and we get 3,455 miles from the observer to the GP. So that's question 2, Anthony. How do you calculate the distance to the GP on a flat Earth? And I know your answer is 69 miles per degree, but you just saw that it's derived from the Earth being a sphere. So you're gonna need R for that, champ. All right, next bit. Riley somehow thinks that we can't measure light that's curved through our atmosphere.
Now, obviously remember that there is no line of sight to the horizontal on their model that's straight because of 7.6R. The line out to the horizon or the set horizontal on their model, because you're looking through the optics of the sextant, is subject to refraction at the rate of 7 over 6R and is therefore a curved line. So their argument immediately fails. Okay? Everything on their model is a curve. It's applying curvilinear geometry. Right? It's not applying Euclidean. There are no straight lines on their model.
Jesus, where to begin? All right. So Riley seems to really struggle with curved lines and how we measure them. So again, enjoy the Muppet vision. Because of the density gradient in the air, light will curve. And this happens regardless of the shape of the Earth. So all we're measuring here is the angle at which light is coming into the lens. So if you want to whinge about an angle needing 2 straight lines, that's fine. We'll just add in a tangent to the curve at the point at which it enters the lens. Easy done. So number 1, light curves regardless of the shape of the Earth. If you want to make a positive claim that light can only bend on a globe, then boy do I have some laser tests to show you. Number 2, we're just measuring the angle at which light comes into the lens. So in reality, the path that light takes is curved, and that's why we correct for it. And we don't just adjust for it in the horizon dip, we correct for it with the elevation angle to the star as well. So again, if you accept that celestial navigation works as is, then you're going to have to accept that it already makes corrections for light bending. Number 3, 7 over 6R obviously only applies to a globe. If you want some formula for light bending on flat Earth, then you're going to have to derive it by yourselves. So not only does 7 over 6R only apply to a globe, it only applies to observations made within a couple of degrees of horizontal. So I don't know if Flurfs have ever actually bothered to look at the almanac, but these altitude corrections for the star get smaller and smaller as the angle gets bigger and bigger, until there's 0 refraction when you are looking straight up. Number 4, and curves exist in Euclidean geometry. Anthony's not the only guilty party here, so all the Flurfs seem to get really confused when it comes to curves and Euclidean geometry. Oh wow, look at that. It's a curve in Euclidean geometry. You remember the equation for a circle, right, Anthony? Maybe you don't. So on the left, we've got a 2-dimensional Cartesian plane, and on the right, we've got 3D space. Both the circle and the sphere are within Euclidean geometry. And this is the two-dimensional surface of a sphere in non-Euclidean geometry. So the point I'm making here, Anthony, is that just because I'm dealing with curves and circles and spheres doesn't mean that I'm bound to a particular geometry. If someone describes a sphere in X, Y, and Z coordinates, then they're clearly using Euclidean geometry. But if someone's giving you latitude and longitude, then the implication is that they're referring to non-Euclidean geometry, so the surface of a sphere. So the context matters. Just because you're talking about spheres, it doesn't mean you're using one geometry over the other. So you can be using Euclidean geometry for something, and then transform those XYZ coordinates into a latitude and longitude and start using spherical geometry. All right, back to Anthony's video.
I know this is begging the question, but I've got to do it for their argument to show how it doesn't work for them. But it only works for us. But we've got Ruhif here, he's on the right hand side, he's on his ball, and he's set in his zenith.
Right, so this whole begging the question bullshit needs to be addressed again. So I talked about it a few years ago, but clearly they are not understanding. So flurfs have enormous issues with this idea of presupposing something like the Earth being a globe. So let's have a look and see if that's a valid objection. So first of all, begging the question is when one of your premises already has the conclusion in it. So it's effectively circular reasoning, and that's an informal logical fallacy. So an example of this might be 2 Timothy 3 verse 16 says that all scripture is given by inspiration of God, therefore the Bible is divinely inspired. Now obviously you can see the circularity in that and why the argument fails. But what flurfs are actually referring to when they say begging the question is usually a formal logical fallacy called affirming the consequent. And it goes more like this. So if the Earth is a spinning globe, then the weight of an object will correlate with latitude, due to the centrifugal force. In reality, the weight of an object does correlate with latitude, and the conclusion is therefore the Earth is a spinning globe. And that, my friends, is a formal logical fallacy. But flurfs seem to think the problem is with the if statement. So if the Earth is a spinning ball, and as soon as you start with that if statement, that's when Nathan will hit his mute button and start his usual pathetic tirade about presupposing a globe. But I do recall flurfs being very fond of this particular argument. And oh, looky here, what does it start with? If the Earth is a sphere with radius 3959 miles, blah, blah, blah. So clearly flurfs don't have any problems with presupposing a globe. They're doing it with the black swan argument, and they're doing it every time they use a curve calculator as well. So what both sides are doing is presupposing a globe for the sake of the argument. Then we go and check the prediction against reality and see if it matches. Unfortunately for the flurfs, the black swan argument fails miserably because it ignores the atmosphere. So the second half of that sentence is just false. So here's a bit of a flowchart for what's happening logic-wise for these so-called globe-killing arguments. So you have some proposition P, and if P is true, then some other proposition is true. So in this example, we're using Riley's Maughold Lighthouse claim from a few years back. So first step is to assume, for the sake of argument, that the Earth is a globe, and then work out what the consequences would be. So you'd plug it into a curve calculator, it would spit out a hidden amount, and you'd use that to declare that you should not see the lighthouse. Then you compare that to what you actually observed in reality. If you did not see the lighthouse, which is what you expected if the Earth is a globe, then whoop-de-doo, you can't make any conclusions from it. If you did make a conclusion of, therefore the Earth is a globe, then you'd be committing the fallacy of affirming the consequent. If you did see the lighthouse, which Riley claims he did, then the conclusion would be valid. Earth is not a globe. Unfortunately for Riley on this particular occasion, he was mistaken about what he saw. And if you're at all interested in how this panned out, I'll leave a link in the description. There are a couple of other errors that flurfs tend to make, and both of them are in that second step. So the one that says, then I should not see the lighthouse. So in this example, there's a hidden assumption that the atmospheric conditions are typical, and that you'll be applying standard refraction. In reality though, the conditions might be conducive to extreme refraction, and under those conditions, maybe you should see the lighthouse. The other error is when they just make a completely incorrect prediction. So for example, the if statement might be, if Earth is a spinning ball, then I should be thrown off like I'm on a roundabout. And if you've ever calculated the forces involved in this, you'll realize that the then part of that statement just doesn't follow. So the argument fails that way. The last point I want to make when it comes to logic is that pretty much every logical argument that flurfs make begins with, if the Earth is a spinning ball. I don't think I've ever seen any flurfs make any sort of positive claim for their position, like if the Earth is flat, then I expect to see X. And obviously they can't do this because they don't have any kind of model. And if they don't have a model, then they can't make any sort of prediction for what they should see in reality. And that's why all you get from flat earthers is just post hoc rationalization. So you'll show them something like Canigou or San Jacinto, where there is 2,000 meters of mountain below the horizon. And they'll just throw phrases like, it's the limited angle, or that's just perspective. And this is why that second step of making a prediction from a model is so important. It shows that you actually have some understanding of how things work. If you can't make a prediction, then you don't know how things work. So sorry for that extended rant. Let's get back to this absolute abomination of a diagram in Riley's video.
Let there be no doubt, we do have the three values that we need. We've got the number one, the measurement of the angle from the observer. Number two, the distance in time of the star to the zenith. And we've got number three, we've got the right angle 90 degree. And at that point, the trigonometry can be done.
Then fucking do it, Anthony. All you Muppets keep claiming the trig works, but no one seems to be able to put the fucking numbers in. And this shit about measuring distance in time. Holy fuck, Anthony. Take your medication. So Anthony, I've answered everything in your video. Now let's see if you can answer me. So the questions again. Number one, how do you derive the horizon dip correction on a flat Earth? And number two, how do you calculate the distance to the GP on a flat Earth? And I mean actually do a worked example like I did in this video. And remember, Anthony, a nautical mile is defined by 1 arc minute of latitude, so you're gonna need R for that, champ.